So my name is Fatih Nar. I'm a distinguished architect at Red Hat. Previously, I was part of Google. Before, it was Verizon Wireless. Many lives ago, it was Canonical, Ericsson, and Nortel back in early carrier days. So what I have learned through my journey, if I start with Red Hat, whatever you do in coding, knowledge building, documentation, collaboration, if you share with the community, it goes way beyond what you can imagine. What I learned at Google is pretty much, if you want to achieve something, you have to experiment a lot, and incrementally experiment and go to a progress. Verizon, I learned to be patient. I was part of the platform team at the Verizon Cloud. Ericsson, I worked in different countries. What I learned is how to handle drinking whilst living in Sweden. And unfortunately, I'm not able to handle it properly because I'm not Nordic. But so at Canonical, I learned that not every tech company destined to bloom, because if there is a one dictator owner, that may dictate the future of the company as well, and that will change your life as well. So today we're going to talk about mainly applied observability in the domain of telecom applications across hybrid cloud, how to use data pipelines and turn into insights and operations. My beloved partner, Jamie, couldn't make it due to health reasons, and we apologize on her behalf. Hopefully she'll going to get better soon. So what we're going to talk is it observable? So as Mr. Observable here, and we're going to talk about why it matters and how we can use the background for the observability using leveraging service mesh, going into OpenTelemetry, eBPF, and turning in those data silos into proper data pipelines to use with the, say, if you have ambition to implement autonomous networks, for example, that how you can turn into those experiments. So our purpose here is to, as I was hinting, what I learned at Red Hat is to share the knowledge so we can grow together. If you're interested, please reach out either through GitHub or through Medium or through LinkedIn. Also, you can scan my badge as well. I would love to get to know you and your passion and what you like to achieve. If it's aligning, if the stars are aligning, who knows? Maybe we will grow together. So why observability matters is twofold. If you don't know what you're doing, or if you don't know what your systems are doing, you're destined to die. And I literally lived through it in my personal life and in professional life. So for me, every step in my daily life to collect metrics and be aware of myself as well as my family, as well as my systems, as well as my applications. So if I have the proper, clean, usable data, maybe I can steer those things, my life, in a better way. And this is true for telecom as well. So telecom applications has evolved a lot in the last 5 years, becoming more microservices, becoming more distributed, becoming more using hybrid cloud with the public cloud as well as on-prem, and now implementing between those different infrastructures the secure connections, say, through different protocols and projects. You have to be more observing and knowing what you're observing too. So what we see in the field is pretty much coming down to enablers, and everybody using pretty much the same enablers for CPU, memory, storage, I/O, and then people just look at it and stare at it, at the one fantastic, I would say, Grafana dashboard. And that's it. That's where the observability dies. But when you ask, okay, I want to go beyond, what can I do with it? I have the CPU thresholds. I can set anomaly detection based on abnormal metrics. Same for memory, same for I/O. Maybe you can predict if I/O going down despite the traffic. Maybe you need to predict that your hardware is about to fail for storage and so on and so forth. But is it enough? It's not enough. Everybody does that. So we need to go a little bit more into application layer, layer 7 in the per se. So there are various options, and we are, as a community, evolving in those options as well. The number one is obviously service mesh. Service mesh evolved a lot, I would say a lot, in the last 12 to 16 months. One of the key challenges and pain points has been the sidecar, using Envoy in front of your application, becoming a bottleneck in choke point for your application traffic. Now, ambient mesh is promising to eliminate that, but yet you are still collecting the metrics from your applications to and from. The other one, just before AI thunderstorm hit, everybody was talking pretty much about the eBPF. The packet filtering in the sense of K-probes, in the XDP, C groups, and so on and so forth. And yet, people didn't talk about what they are doing with those. What are you collecting? Oh, I'm collecting user space information about the CPU, which process calling which process, what are their process IDs and their priorities. So what are you doing with it? Maybe you're creating on-the-fly dynamic tracing for backend, for storages, as well as maybe your DB. But then it becomes so obvious if you have attended the, if not, it was a great session today, eBPF deep dive. It's such a great, yet I would say dangerous area to deal with the eBPF at kernel space. You can easily mess up things. And when you mess up things in kernel level, I wish you the best. So this is what happened last year in one of the biggest tier ones in the US in telecom. So partner comes, observability partner comes, and install their highly privileged daemon sets across the, I think it was 1,500 node OpenShift cluster Kubernetes. And what we noticed next is our multi-cluster management pods becoming preempted, as in the bottom. And we were just going, obviously, in a shit show, pretty much, because it's a big cluster, it's a live cluster, and our management pods are getting preempted. And we debugged down to, oh, this partners didn't properly do the sandboxing to test the impact analysis with respect to the rest of the system. And we couldn't recover the cluster in automated way. So what we need to do, every node we have to SSH into and delete those daemon sets one by one. And that's how we recovered that cluster. So what's the lessons learned? If you're going to use eBPF, make sure whoever maintaining that platform as a platform team or a technology provider for a platform software, let's do the due diligence about what sort of programs you're loading. And if there are already other tenants loading eBPF programs, are they overlapping? Are you preempting the other ones? So these are the lessons we have learned. So that's why we kind of donated the bpfman to the CNCF as a key project to have a proper guardian of loading eBPF programs into the Linux kernel, at least for Kubernetes-wise. So Red Hat has multiple products in the field. One of them is, obviously, you probably aware, is OpenShift. On top of OpenShift, there is Advanced Cluster Security, Advanced Cluster Manager, so on and so forth. Most of these technologies or products being used eBPF. The one you're looking here is Advanced Cluster Security, StackRox, that we did acquisition 2 years ago, I think. Using eBPF in the K-probes as well as in the C groups manner to understand the CVEs, the network throughput, so on and so forth, packet drops. We have another operator in our operator marketplace called NetObserve, observing the network interfaces of your applications. This is using pretty much the XDP as a program domain with eBPF, showing the latencies and throughputs, and as well as the packet drops between applications and between clusters. So these are the basic things. So the challenge is not necessarily technology in observability domain. The challenge is to educate people how to use it properly in developer domain, as well as in platform engineering domain, as well as from the strategic perspective. That's why our journey with observability, I would say 20% technology, 80% talking with people to understand what is their showstopper. In 80% of these cases, when we drill down, they say it's too complex to use. It's too complex to understand. I have no time to study these OpenTelemetry libraries. I have no time to understand how eBPF works. That's where we come in with the enterprise observability experiments. Literally, we just chew the food and ready to give it to the mouth of a little bird to understand, to digest how you can instrument the code with Go, with Python, with Java, and straightforward sync your data into OpenTelemetry collector From there, you can export the data through OpenTelemetry into Dynatrace, into Splunk, wherever you like to go, or your own OSS system, operational support system. There are various architectures you will see in the market. Pretty much, I would say 99% similar. It's starting from obviously the physical layer with the redfish and gathering those hardware telemetry data, and then OS with or without eBPF. And platform layer with the Kubernetes metrics, and all syncing into local node Prometheus instances. From there, you can trigger Kafka events and deliver those. And or you can do tenant space application level telemetry collection. We are really kind of small steps in this world with the great partners such as Ericsson, Nokia, Avenir, Samsung, into getting them into directly using OpenTelemetry instead of we do black box harvesting with eBPF. Some of the missing things because of the lack of the use of the OpenTelemetry libraries, we are trying to cover that gap with the eBPF on our side in the name of our customers. But having an add-on observability with eBPF has challenges for twofolds. One is we have to know inside of those applications to know what to collect, which processes we need to dip into, how to correlate those in east-west communications, so on and so forth. That's why we are encouraging our partners to use more and more, if possible, with our help, OpenTelemetry instead. All right. I usually don't like to talk too much, and that's one of my challenges in my marriage. My wife says I don't talk, but here I am giving a speech. So under Open Experiments, we have five experimental projects. One is Telco AI experiment. Other one is, which we looked, Observability experiment, and Sandbox 5G. Sandbox 5G, if you're familiar with the Open 5Gs, it is the open source 5G implementation full stack together with the radio access network simulator, which we use all these to telemetry data to come from that Sandbox project. And this one, with the Sandbox 5G project, all the CNFs, cloud native network functions, say AMF, SMF, whatever you like to name the other CNFs are, they are working loaded with the traffic generated with the UE runtime and sending those metrics to OpenTelemetry. From there, we are exporting to Prometheus. From Prometheus, we are visualizing with the Grafana. This is, again, you can go and deploy. You know, I'm a Bash guy. That's why I heavily use Bash for automating the things. And this is ready to roll in your cluster, in your Sandbox cluster. Not obviously, don't use it for production. Don't expect that this is going to be supported for production-grade 5G or something like that. But this will give you an idea about how to use OpenTelemetry. Because these are real metrics, endpoints being harvested, and sync into OpenTelemetry collector, and from there we export. Okay, so everybody, as being in the age of AI, what are we going to do with the data? Before we head to the data, there's another famous, I would say, popular word called agentic. So in enterprise platform domain, agents are not new things. Agents has been there. We had the DNS agent, we have the trouble ticket agents. Agent means a piece of software that does deliver a desired programmed workflow part. Means it has a duty, a role, and it fulfills its role as defined, and talks with the other software pieces to deliver the outcome or being served for helping. So in that sense, in this experiment under Telco AIX, it's autonomous networking project. So we have four different agents. One is the diagnostic agent. What it does is it gets the metrics, KPIs from those CNFs from the Sandbox projects, and performs a data stream analysis for anomaly detection. Anomaly detection could be there could be different options, such as you can use classic ML, applied ML. Say, oh, I'm going to use linear regression or logistic regression or decision trees and so on and so forth. And here it does apply and detects the anomaly. Once it detects the anomaly and passes that event to a planning agent, says, hey, they are talking peer-to-peer using ACP protocol, agent communication protocol. It says, hey, I detect this anomaly in AMF. The CPU is going to the roof, traffic is increasing. So the planning agent uses the MCP protocol, which is Model Context Protocol, to a backend and asking, hey, I have this anomaly detection back with these logs, and passing the MCP server to provide what to do with it. MCP server responds and delivers a remediation path, and then the resolution agent runs that recommendation, and validation agent verifies issue is cleared by means of looking at the new logs and metrics. So we got the data stream came, we did anomaly detection, we did the RCA, root cause analysis, and with the help of MCP backend, and then the remediation, in our case, obviously we have Ansible playbooks. So Ansible playbooks are running based on the remediation recommendation from the MCP. Say running a scale up the AMF instance. Oh, maybe restart the UPF because it's something weird happening in the application layer, and they are checking the liveness and health checks that playbook runs. And we have a small demo too, if I can run quickly here. What you're going to see is pretty much what I have described. Let me pull this down and run it slowly. So the metrics are flying. The top, you will see a processing speed. This is a data sampling speed out of the data pipeline coming in from AMF, SMF, and UPF metrics. And the anomaly detection is the diagnostic agent is running for anomaly detection. We are, in this experiment, we are enabling you to use other MCP backends as well. Here goes the metrics for each individual agent and predictions and alerts. Each agent's health status, even obviously they are a piece of software, they are consuming resources out of the cluster, which we are representing here. And active workflows, the remediation path, there's an anomaly with UPF, what to do, or running this playbook, which is predefined. Hopefully when this project goes through, we'll have these playbooks not necessarily static defined. It's going to be dynamically created on the fly based on the diagnostic agent's output coming from the MCP backend. So, long story short, what we have looked at is collecting proper data out of application layer together with the platform, associating that data streams, in running those data streams using agentic approach, detecting the anomalies or classifying the data based on use cases, then triggering the next workflow. Next workflow is, what am I going to do with anomaly? What am I going to do with this trap or alert? And then leveraging, I'm sorry calling this, but leveraging the LLM backend through MCP server, and then you go, so smart, so amazing, so wonderful, everything is awesome. No, it's not. So we have a lot of issues when we were designing these systems. What Gen AI model are you gonna use? Which one is good? Where? So say distributed systems have layers, say central data center, regional data center, edge. In each layer, you have limited resources for GPUs, CPUs, memory storage. When you go from central to edge, resources becomes more expensive because footprint is small, you're renting those spaces, and since the footprint is small, it's so precious. So then it becomes, what shall I do with the data where? So these are the questions we are tackling pretty much every day. Where shall we identify the problem? Where shall we fix the problem? And to fix the problem, obviously going back to step 0, what sort of data I should collect, what layer? Collecting data, okay, you passed the collecting data step. You're great. You're doing OpenTelemetry, eBPF. What are you going to do with the data by means of life cycle of the data? If you store everything you received and you collect it, that's another cost item for storage, for lifecycle management. What we see in the field, I think most of the telcos are enterprise and healthcare as well as defense as well. Oh, let's not delete the data anymore. So enterprise work through, we collect everything and then we delete everything age, and now we are past that. Okay, we should save some of the data, not because only for regulations, but also maybe we'll need it at least 7 days of back-propagated data for issue root cause analysis. So in each layer, observability differs. In each layer, operation differs. And this is pretty much use case driven. And in telco AI experiments, we have 13 use cases. One of them is revenue assurance, service assurance, IoT perimeter security. It goes. One last thing I would like to say from our experience from the field. I live in Dallas, Texas, and I have worked at Verizon. And one of the data points kind of harmonized from service providers, it was using the light sensors at the edge locations. So there's cell towers and radio stations. They don't have cameras. It's expensive to deploy cameras because there are thousands of those radio stations. But there are sensors for heat, ambient light, and movement. So we use those data points to detect the security, physical security issue, as well as break-in and theft. So what we found out of that historical data of 4 years, in Texas, in summer, people go crazy, which is obvious. But we were not expecting them to shoot with their guns and pistols aiming to radio stations. Apparently they do. So what do? Now we know what month, what week, what day, what radio station is being aimed at, in what neighborhood, okay? So you can take a precaution on that. So another one is, in New Jersey area, the second headquarters of Verizon, we always in Texas call the first one is Texas, but anyway, Jersey area, one of the key indicators from the data insights is right after Christmas, things get crazy. Why? So that's a speculative answer, but apparently people overspending in Jersey area for Christmas, and they're finding ways to comprehend and pay their bills, and we see a lot of high CPU memory being black marketed right after Christmas. So now we see a lot of people talking, I'm going to run AI inference at edge. Okay, Dad, you're buying a 20 grand a pop GPU you're going to put at the edge. I would like to see how they sustain by means of staying there, because this is a tough, not only for maintaining heat and temperature, but also break-in as well. So I hope you enjoy this conversation. If you have any questions, feel free to shoot, but this is all.